Algebra 2 less than 8.5. Properties of logarithms is part number 2, picking up on example number 2. Expanding and condensing logarithms today. Expanding a logarithm, you have log base 4 of x squared over 3y cubed, assuming x and y are positive. So you have to start off with the fact that x squared divided by 3y to the third. Remember, division pairs with subtraction according to the quotient property. So separate it. We're making something now, when we're talking about expanding logarithms, we're making something now that's very short into something that's going to be very long when you write it out. So we have log base 4 of x squared minus log base 4 of 3y to the third. The next thing you want to do is you want to separate this here. You have multiplication happening here. 3 times y to the third. So just like we separated division to start by subtracting it, now you separate multiplication by separating it into addition. From there, you want to move the fact that you have exponents up front of both of these. So when you move your exponents up front, it becomes 2 times log base 4 of x minus log base 4 of 3, that one doesn't change, plus 3 times log base 4 of y. Again, that is your power property. So your simplified version, now you have one more thing. This says simplify here. We think of that more as the distributive property because you have to distribute this negative 1 to here, and it becomes minus log base 4 of 3, and also to here, minus 3 log base 4 of y. So it went from something very short to something that we consider very long. But if we had approximations of these, this would be a very simple thing to calculate, just like we did on example number 1 and just like we did on our homework and bell work today. So on the back, everybody, let's take a look at this one. You still need to look at that? Okay, we'll go back to it for a second. Okay, on the back, expand log base 5 of 2x to the 6th and assume x is positive. This is one less step than we had to do on the example, so this will be a little easier. Take about 30 seconds on this one. Okay, separate the multiplication first. So separate this from this. So you would write it as log base 5 of 2 plus log base 5 of x to the 6th. So that's separating the multiplication. Then you have one more step. You need to bring the 6 up front of this one. So it becomes log base 5 of 2 plus 6 times log base 5 of x. This is the expanded version. That was expanding them. Here is condensing them. Okay? So now we're just going backwards of all of that. So you have log of 3 plus 3 times log of 2 minus log of 6. The first thing you do is you want to move this 3 into the exponent position. Again, everything's backwards, the power property. It's backwards of what we did on example number 2. So this goes here, and it becomes an exponent of 3. So now you have log base 3 plus log, I said log base 3, excuse me, log of 3 plus log of 2 to the third minus log of 6. Then you want to put together the fact that addition here pairs with multiplication. So log of 3 times 2 cubed minus log of 6. Then you want to put together the fact that minus here pairs with division. So it becomes log of 3 times 2 cubed divided by 6. Okay, we get to log of 4 by doing 2 cubed, we know is 2 times 2 times 2, which is 8. 3 times 8 is 24, and 24 divided by 6 is 4. So that's how you get to the log of 4. So we condensed something that looked very long on this first line here. We condensed it to something very short, the log or the logarithm of 4. Let's see if we can do the same thing on the back. Condense this one. 2 times log base 3 of 7 minus 5 times log base 3 of x. About 30 seconds on that one. Okay, again, first thing you want to do, move your coefficients into the exponent position. 2 goes there and 5 goes there. So you have something that says log base 3 of 7 squared minus log base 3 of x to the 5th. So that's moving the coefficients to the log position or the exponent position. Then remember, subtraction pairs with division. So make it say log base 3 of 7 squared divided by x to the 5th. And there's one more thing you can do. You can simplify 7 squared. So you're left with something that looks like this. Log base 3 of 49 over x to the 5th. And there's nothing else we can do with this problem. That's condensing as far as we can go since we don't know what x to the 5th is or what x itself is. Okay, this first one, number 3 on the checkpoint, tells us to expand this one. So we're making something very short into something very long. Remember, we want to work backwards through this. You want to separate, if you go back to your example that we did when we expanded it, the first thing we did is we took away the division, then we took away the multiplication and division from that. Then we did the power property last. So it's backwards of what we just did for condensing them. So the first thing you want to do is separate it, make it look like this. The log of base 6 of 9x to the third minus the log base 6 of 2y squared. Now, what you're going to be tempted to do here is you're going to be tempted to try to shortcut a lot of things like I showed you guys when we were doing the bell work and the homework. Okay, when it's asking you to expand it, though, don't shortcut it because you're going to leave something out and you're going to forget to put it into the final answer. So from here, separate the multiplication of 9 times x there. And you could separate the multiplication of 2 times y there. So we have is log base 6 of 9 plus log base 6 of y cubed minus, now here's the key right here, minus, it's minus the whole thing. So it's minus all of this. And if you look back to example number 2, you had to do this for this one too, anytime there's minus. Log base 6 of 2 plus log base 6 of y squared. What we have to do now is we have to move this exponent and this exponent. This has to go here. This has to go here. There's no other exponents to move. So you have log base 6 of 9 plus 2 times log base 6 of y minus log base 6 of 2 plus 2 times log base 6 of y. And there's one more thing to do. There's this negative 1 that needs to distribute to this and to this. So it becomes minus log base 6 of 2 minus 2 times log base 6 of y. The rest of the problem will stay the same. Log base 6 of 9 plus 2 times log base 6 of y. So as long as that looks, that should be what we have. Okay, so look at the one thing that's missing right here. Okay, why do we have log base 6 of 9 plus 3 times the log base 6 of x? Okay, I wrote it down as an x, but same thing. Minus log base 6 of 2 minus. Okay, I caught the error. On the second step here, it's a 3 that we had to bring up front. And look, I brought a 2 up front. So it's not 2, it's 3. Other than that, I just wrote a y instead of an x because I looked at the right side instead of the left side. Be careful with that. 3 log base 6 of x. And now that matches what we have down there. Minus log base 6 of 2 minus 2 times log base 6 of y. Condensing logarithms, people usually like doing those a whole lot more because your problem gets shorter instead of longer, and that's when we solve problems. We typically get shorter instead of longer, so it feels weird to expand one. So if this feels weird to you, if you're looking at it like I have no idea how to do this, it's actually not as hard as it looks. It's just not typically what you do in a math class. You don't make things longer, you make things shorter. For this one though, you work backwards though. You move the coefficients, if there are coefficients, you move them to exponent form. So move them here. So log base 3 of x to the 4th minus log base 3 of y to the 3rd. After that, subtraction goes with division. So it's log base 3 of x to the 4th divided by y to the 3rd. And this is all we can do with this since there's nothing, we don't know what x or y's value is. And again, condensing seems to be and feels a whole lot better than expanding for most students. Okay, the change of base formula. Anytime you have different bases, okay, we've been dealing, up to this point, we've been dealing with things that have the same base or they've been easy changes of base. What I mean by that is changing the number 25 into 5 squared. That's an easy change of base. Sometimes you won't have that, it won't be quite that easy. You won't have that luxury of doing that. So it's saying let A, B, and C be positive and let B and C not be equal to the number 1. The log base C of U is equal to the log base B of U divided by the log base B of C. In particular, when you have the log base C of U, it's log of U divided by log of C. So what this means is the same thing, and when numbers are applied here, it looks a whole lot easier than all of this log stuff with U's and C's combined. What this is showing you here is that if you use the logarithm, it's the exact same thing as using a natural log. So it's going to ask you to do the natural log on one of the examples, but it's the exact same thing. You're going to come up with different numbers, but when you divide them, it's like multiplying the same thing by the same number. It's going to change your number, but at the end, it'll come up to be the exact same thing. So this is how you use the change of base formula. It says evaluate log base 6 of 6, log base 5 of 6 using common and natural logarithms. So the first one using a common logarithm, that's just logs, not the ln. Log base U over log of U over log of C, which is equal to the log. Now, this is all you have to know. You can almost you can almost ignore this part here. It's the log of whatever you're talking about is going to be, this is going to be your top number. That's the top, or the numerator. That's your top. And this one here, the base, and bases we know are bottoms, just like they always are. Base is at the bottom, so you won't make that mistake. So it's the log of 6 over the log of 5. Notice this is an approximation here. The log of 6 is approximately 0.7782, and the log of 5 is approximately 0.6990. So 0.7782 divided by 0.6990 is approximately 1.113. That's using a common log. That's just using logarithm. You're going to notice on the next one, you're going to come up with different numbers, but at the end, we're going to still get 1.113 using natural logarithms. So instead of log of u over log of c, it's natural log of u over the natural log of c. So what that is the natural log of 6. Again, the big number is the top. The base is the bottom, the natural log of 5. Notice these two numbers are different. These two are not the same as these two. They're two very different numbers. However, when you divide them, you're still going to get 1.113 because the common log versus the natural log are different numbers, but it's still dividing by the same thing. And again, change of base is the one thing that this has all been built into. This is the most useful part of it when you don't really want to do it or you don't feel like you can do it. So right here, evaluate the log base 4 of 8 using common and natural logarithms. See if you can set it up at least. If you have a calculator, punch it in. If you don't, just set it up and just wait a few seconds till we get it filled in for you. So when you set it up with common logs, it's going to look like this. It's going to say the log of 8 divided by the log of 4. That's how you should have it set up. The same thing when you do natural logs, it'll just be ln, or the natural log of 8, divided by the natural log of 4. Again, you're going to get two very different numbers when you do these in the middle of the problem, but at the end, you'll come up with 1.5. Okay. On your calculator, you may have to close parentheses out if you didn't get 1.5. Some calculators act a little funny if you don't close the parentheses. 1.5 is what you should have. The log of 8, if you just do it that way, you're going to get something that's approximated at 0.903, and it continues, over the log of 4 is 0.602, and it continues. When you do the same thing with the natural logs of 8, you get a very different number, 2.079, that continues. And the natural log of 4, you get a very different number again, 1.386, and that one continues. But both of these, when you divide them by each other, this becomes 1.5, and this becomes 1.5. So using the common or the natural log gets you to the same solution. So evaluate the log base 7 of 9. It says using natural logarithms, it doesn't make a difference. So right here, what you have to remember is that this is the top number. So the natural log of 9 over the base is the bottom number, the natural log of 7. Again, if you use log instead of the natural log, you get a different number at this part, but this is approximately 2.197 over the natural log of 7 is 1.945 or 1.946, I guess. That one should round to. And when you divide those by each other, the natural log of 9 divided by the natural log of 7, and you're definitely going to have to close your parentheses if you do that, because it's going to Try to do it all in the same spot. If not, you'll get 1.129 for that one. 1.129.